All right, so everybody can see the screen. I'm having that same issue as I did the other day where everybody is, I lost all the images of everybody. It's interesting.
Oh no.
Uh-oh. Hang on, let's get the views. There we go. I got my views.
All right.
Oop.
So I don't know, maybe you'll pop, I can hear everybody, I just can't see anybody. But as long as you can see my screen and I can hear you, that's good enough. Okay, so for today, we were supposed to use our modified insertion sort and apply it to player objects and sort them on their age. So we're going to, so the exercise there would be to take what we did last time and expand it to say, well, what if I wanted to apply this logic to similar types of things? Instead of sorting numbers, I want to sort other things that are sortable. How do I need to modify this to make it work for that? All right, so down here in main, I've already created a list of players. So we went ahead and we said we're going to have an empty list of players. We decided we're going to have 100 players. We filled it up with 100 people with first name, last name, so on and so forth. And they have ages and between 15 and 75, a jersey number between 0 and 99. Then we went ahead and we created that new player object and we added it to our list. So after this loop is done, list of players should be filled up with 100 player objects, distinct player objects. And if you remember from, I told those players to display themselves, but just as a quick reminder here, if I take this code out for a second, we'll put it back in, I promise. And we instead just print out each player. So this is, I'm printing out each element that is in my list of players. So it's going to show me the value that lives inside of list of players. And we see we get a bunch of memory addresses for each of the distinct players that's in there. Okay. So that kind of shows us the kinds of values that players are, that objects are. Objects give us memory addresses which point to where that object actually lives in memory. If I then want to use that, make sure everybody's muted. We'll have a way of, I think that muted everybody. So you could unmute yourself to ask a question, then remute yourself. That's fine. Okay, so if I want a player at one of those memory addresses to actually do something, I could ask that player to call one of his functions like display, for example. And now that player, so now what's happening here is Python is resolving this variable. So it's resolving that memory address to the actual player object that lives at that memory address. And he's asking that particular player object, who refers to himself as self, to call his display method, which knows how to display a player. All right, so notice the difference in the output that we're getting here. We're getting each individual player displaying themselves, as opposed to printing what a player is. That variable holds the memory address of a player object. All right, very rarely is this memory address going to do us much good, other than proving to us that it's a memory address, and that reminds us of the kinds of things that are happening. For instance, if I pass a player into a function, or a list of players into a function, now it's doubly true what I'm about to say. If I pass a player into a function, that player is being passed by address. Why? Because he is an address. Every day of the week, he's an address. So if I'm passing it by address and I make a change to that player, that will be a permanent change because I am changing that player in memory, even if we can refer to him by 2 or 3 or 20 different variable names, all pointing to the same place in memory. If I'm passing a list of players, so let me go ahead and put my, well, here, I'll just go with that. If I'm passing a list of players into my insertion sort, any changes I make to any kind of list, so lists are also passed by address. Any changes I make to a list will have side effect. They'll be permanent changes. That's why we're not returning a value from insertion sort players. Insertion sort players will update this variable in memory so that from that point forward, it will be the new list of players or the modified list of players. All right, so now let's go ahead and write our insertion sort for players. One of these days, I'm going to remember to update the scroll speed. All right, so notice here, indentation-wise, that our insertion sort does not belong to the class player. Insertion sort is a standalone function that knows how to perform stuff on whatever. In this case, that guy's a list of numbers, and the one we're writing today is a list of players. So what I'm actually going to do is I'm just going to start. I'm going to copy our code over from before, because it's the exact same algorithm we are running. But instead of comparing the number that lives at the bucket the follower to the number that lives at the bucket the follower minus 1, we want to compare the age of that person. So list of players is what we now call list of numbers. So this is the different list we are operating on. I'm just going to update all LONs to be list of players. All right, so far I haven't changed any logic. I just updated my variable name because this particular function takes in a variable called list of players, where the other one took in a variable called LON. So now all occurrences of LON have been replaced by list of players. So same logic. All right, but no longer are we comparing a player. So this guy that I have highlighted right there, he is a player object. He looks like this. All right, so I can ask, is this memory address less than another memory address? I actually don't think Python likes that. But regardless, in general, and it's the reason it's not liking it is because of the way the memory address is resolved. But in general, a memory address is a hexadecimal number. And I could legitimately ask, is this hexadecimal number less than this hexadecimal number? But that's not what I'm interested in here. I don't want to know if the memory address of a player is less than the memory address of another player. I'm interested in whether a certain player's age is less than another player's age. All right, so before we go any farther here, I'm going to go ahead and print something here. So how do I get a player's age? Well, again, if I print a player, I get the memory addresses of that player. If I ask that particular player to resolve himself and then give me his age field, now I get the ages of all those players. Okay, so a player can resolve himself from his memory address to the actual player object and then ask that guy who refers to himself as self to give you his age. All right, so we go back up here, and now the question we're asking here is not whether this player is less than another player. We're interested in whether this player's age is less than this player's age. Okay, this is not me having a list call an age field. Even though this guy looks like it's a list, he's actually, because we see these square brackets here, so we might at a glance decide, oh, he's a list. But we have to think, what does syntax resolve to. So when I highlight this, that guy right there resolves to a player. That's a player that lives at bucket, the follower, inside of list of players. So what I have highlighted will ultimately be an instance of player, and that instance of player has an age field. So I'm asking, is this player's age less than this player's age? If it is, we are not going to swap those two players' ages. We don't just get to point at two players and say, okay, now you're 17 and you're 28. You know, we don't get to just update their ages. We're going to have those players switch places in line, the actual entire player. Okay, so we're going to say temp will be equal to the player that lived at bucket follower. Then we'll overwrite in our list, position the follower with the guy before him. This is, I'm overwriting this spot in line with this player. Then I'm overwriting this spot in line with the player we had temporarily stored in temp. And then the follower follows. So notice I didn't change any of the syntax for logic, except the question I was asking. Am I comparing the numbers before? We were comparing the numbers that lived at two positions in our list, as opposed to this case, I'm comparing the age of players because of the two numbers in the list, or two players in the list. So now we'll see. I'm going to go through, and I showed you last time the two different ways to go through this list. So the first thing is I'm going to ask all the players to display themselves. Then I'm going to call my insertion sort on list of players. Again, it does not return a value because a list is passed by address. And when I make changes to that list, those will be permanent changes. So when, presumably when this list is, when after this call to insertion sort player ages, this list has now been modified to be sorted in the order of age. Then I'm going to go through my list of players again. Notice I showed you an alternative way of going through the for loop. So this is a for each loop that makes a player be equal to each element in list of players each time through. So the first time it would be a player at bucket 0, then a player at bucket 1, a player at bucket 2. We're down here, I'm actually getting the index. So I'm getting the bucket 0, bucket 1, bucket 2, and then using that index to get me the player at bucket 0, the player at bucket 1, the player at bucket 2. All right, so both of these guys will have the same outputs. I'm just accomplishing it slightly differently to show you the second version gives you access to the index, and then you can do whatever you want with that index, including getting the player from the list. But what we should see here is our second printout should have our players ordered by their ages. So here's a pretty old player, age 74, age 73, 73. If I scroll up a bunch, you should start seeing younger and younger ages, 66. So it looks like this guy is sorted on ages. All right, but if you're ever playing a sport, don't just necessarily pick the young people. Sometimes the older folks have a lot more experience. But I don't know. It's possible you want to, if you're, you know, picking a team, and you might want to steer clear of the 70-year-olds, maybe. You know? It could be a, you know, it could be a performance issue there once you get to a certain age. All right. So, any questions here as to how we completed this assignment? At the end of the day, all we changed was this right here, the question we were asking. Questions about that? Okay, so now that we've kind of played around with this insertion sort, I'll go ahead and throw this version of the code up on Slack so we have it. We want to start doing things with our players. And as Skylar was asking for when we came into class, we're going to build a fantasy game with our players. So let's see, player sort on age code. Okay, so I have that up there. So for right now, I'm going to go ahead and I'm going to gut our insertions. Ooh, I don't want to get rid of main yet. All right. Somebody remind me at the end of class to update my mouse speed on Linux. That. Get rid of these guys. All right, so now we're in the player. All right, so what we want to do is we want to build kind of a little game. I want to introduce something. This is going to be a little bit of a short history lesson, but many of you have played these. Oh, there's an update available. Can I say not now? Good. All right, so many of you have played, you know, modern video games. Come on. All right, hold on. So what does, when I say to give me a, wait, am I not on Apple's App Store? Where's my App Store? I don't see an update for Keynote. Just close Keynote here real quick, let it finish that update so it'll let me update the stuff. But I'll say this out loud for a second. So many of you have played these modern day games, whether it's something like World of Warcraft or any other massively multiplayer game, regardless of what you're doing in the game, whether it's a shoot 'em up war scenario type thing, or it's a fantasy role-playing game like World of Warcraft, you know, whatever it is, you've been in these worlds where you have a player that can traverse the world. Some of these are multiplayer worlds where you have a whole bunch of people in the world at the same time and you're playing online and running around. Other ones are single player games that typically have better graphics because they're not having to manage all the network stuff of having you know, 5,000 people on at once. But we can wrap our mind around this idea of a game that puts our player, the person we're controlling, inside of a virtual world that they can traverse, they can go through. Well, today we are spoiled. Back a long time ago, we had something called multi-user dungeon. So think about this as like our early days of Dungeons and Dragons. You know, used to be tabletop type role-playing games. And then they decided, you know what, we're going to make this game online. And it looks something like this, all text-based and you know, and what's funny is I used to play these pretty heavily. This is back before, you know, graphical games existed. And I played these games heavily, so you would move around from room to room to room inside of this dungeon, and there might be monsters in there, and you could fight the monsters and all sorts of stuff like that. But your entire visual was a, here's like probably a fight scene. Your entire visual here was text scrolling on the screen. And actually what we're seeing here is a more advanced version of a MUD where you actually got to see the map and stuff like that. So we're not even gonna go this far. This was a top tier MUD. In the, you know, the real MUDs were just text. and you had to go into a room and see that there was a monster there, and you had to attack the rat or whatever it was, and you had to use your imagination to figure out what the game was. Well, we're going to create a dungeon crawler that is going to allow our single player to be put into this virtual world. And it's going to be a text-based virtual world made up of rooms. So if we're going to kind of draw our picture here of what we're going to do with. So now we're taking our idea of objects. So at this point, we've created several different objects. We've created fractions, and we've used fractions to do some adding. We've created some players and had players sort themselves and things like that. Well, now we want to start creating a program that maybe brings multiple objects into existence. Now, one thing to kind of think about, so solutions using objects. And you actually see this in some of the modern day game builder things, even like Unity, which is something that even like modern day Xbox games and stuff like that use as a game development tool. They kind of portray this idea that we want to think about what we're seeing on the screen is kind of like a scene in a movie. All right, so this is what we see. Now, when you're thinking about a movie, you want to think about what are the players, who are the, what things are on the screen, what things are involved in the scene to make the scene work. So when the director for us is like the programmer, right? We're the one who's directing all the action and what should happen. But when the director calls people to the set for them to film this particular scene, who are they asking to get in there? They're asking the actors to show up. And you know, there's going to be all sorts of different actors. We're going to have the good guys and the bad guys, and maybe there's going to be some pets running around. You know, so there's different live things that we expect to be on the scene. So you know, these are going to be the actors. And actors come in a whole bunch of different flavors. We might have humans, we might have animals. We could have also inanimate things like a chair, you know, so on and so forth. So these are the things that need to inhabit our set. Well, now when we think about our scene is made up of a set. So we can think of this in our little thing as maybe a room in our dungeon. And inside that room, we have some actors, where actors are humans or animals, or maybe there's a chair in there or something else. So there's things that inhabit the particular room that we're in. And some of these things might be human controlled. So for instance, you know, we might have a lot of times we have humans that are both NPCs, non-player characters, and we have humans that are player controlled. Usually that's just going to be our guy. So when you think about a video game you've played, even if it's like Super Mario Brothers, something like that, you know, you're controlling Mario or Luigi as he's jumping around on the screen, and you press the button and he responds to your actions. But there are other things in that scene that are not controlled by you, the little mushroom guys, the flying turtle guys, you know, all the little other actors that are played into that scene. All right. So as a programmer, we're starting to visualize. Now, right now, we're kind of thinking about it in terms of a game, but writing a game is really no different than writing a business application. You know, at some point we have to start thinking about what are the intricacies of a game that you maybe, you know, you wouldn't see the idea of hit points in Microsoft Word, where, you know, in Microsoft Word, you don't decide that you're going to get into a fight with the, you know, the carriage return or the end of paragraph symbol or something like that. So maybe the things you're doing in that program might be a little different, but the approach to solving that problem is going to be very similar. All right. So we want to, when we sit down, we want to think about, okay, who is going to be in our scene and what do they need to do? And that's going to kind of tell us the type of objects that we need to work with. So we want to create initially, I'm going to draw a picture here. We're going to create a little dungeon. Well, I lost my colors. Oh, that's weird. So they're saying that's better to not have colors on those? It might be, I don't know. So we'll call this a room. We'll call this a room. Maybe this room was here. We have another room here. Another room like that. Here, we'll get Christian worldview in there. Our dungeon looks like a cross. All right, so this is our dungeon. All right, and maybe this is our entrance point. So we have an entrance point into our dungeon. So this is kind of like us sitting at the meeting for the movie, sketching out what's going to be in this scene before we actually go and make it happen, before we actually execute it. Okay? So we're going to decide, okay, this is where we're going to enter the dungeon. So, you know, from here we can kind of go north. From here we can go north again. From here we can go west, east, or north. Or we can go back down south. So, you know, this particular room has lots of exits in it. All right? So, you know, these are going to be what our rooms look like. Now, we want to think about, well, what does each room, when you walk into a room in your house, so let's think about your house as being like your dungeon, and you walk from room to room to room to room, you look around and you kind of give a description to that room, right? So let's think about, what is a room? So a room in our world, you know, is going to have a collection of inhabitants, okay, where an inhabitant might be a player in our little thing. That's the person we're controlling. And then maybe some NPCs eventually. For right now, let's keep it simple. A room, the simplest form of a room is it's going to have a player in it. A room will also, well, let's actually say a player in and of itself will have a, let's call it list of inhabitants like we had before. Because if we are just entering our dungeon here, this room up here currently has no inhabitants in it until we start adding new non-player characters to our game, let's say. So most of these rooms are empty rooms in terms of inhabitants, but when we first get dumped into our game, this very first room is going to have us in it. We're going to say it's going to be a list of inhabitants because we kind of expect that eventually we're going to have more than just a player in the room. We're going to be part of the other things that are in the room. All right. Maybe there's a bunny hopping around in there, or, you know, fantasy world, a goblin or something like that. You know, but at home, maybe there's a sofa or a kitchen table or something like that. All right. So a room is going to have a list of inhabitants. It's also going to have a description. So imagine if you're walking around your house, each room you go into, you kind of just, you know, say out loud a couple of sentences that let you know what the, you know, what's the description of this room. You know, it's a brightly lit kitchen with, you know, last night's dinner not cleaned up or something, you know, something like that. You know, so a room might have a description, because keep in mind, with these old school multi-user dungeon games, you don't get the visual of seeing the room in all of its glory. You know, you don't get that value of a picture tells 1,000 words. Instead, we're going to have to put it into words. And from a old school multi-user dungeon player, you don't want those words to be too long because nobody reads them. You just read kind of the title and the description. So we're going to have maybe a title for the room. So title might be like the kitchen, or the living room, or the bedroom. Those are the titles of the rooms. And then the description will kind of give a brief description of what that room looks like. Something along those lines. All right. So here's our, this is what we're going to say a room is. Now a room is also, well, here, before I just give it away. These are our rooms. So each of these rooms will have a title, it'll have a description, it'll have a list of inhabitants in it. What else does this particular room have, the one I have highlighted? Anybody can answer, and make sure you unmute yourself before you answer and then remute yourself afterwards.
I mean, it might have inanimate objects, like maybe props in it.
Okay, yeah, so those right now are kind of fitting into our list of inhabitants, even though we're going to keep it pretty bare bones. But yeah, so what else?
There's
A
no gyms for
door?
the room.
A door. A door. We need to get to this room, right? So now, how many doors does this room have? That room has 4 doors, right? We can go north, we can go west, we can go east, we can go south. This room just has 1 door, presuming you can't leave the dungeon. Once you're in the house, they lock you in, something like that. So maybe it has an exit door as well. But, if we just look at the picture here, this room has 1 door to the north. This room has 1 door to the north. This room has 4 doors in all directions. This room has 1 door to the east. This room has 1 door to the west. This room has 1 door to the south. So a room will also have a collection of exits or a collection of doors that lead you to another room, right? So we're going to have in here also a list of exits. All right, and some of our rooms have 1 exit, some of our rooms have 4 exits, and everything in between. All right, because something that we want to be able to do is we want to be able to walk through our dungeon here. We want to be able to be plopped into this first room and then have our player be able to give instructions, maybe, say north, and have our player move from this room to this room. And then the player says north again. He moves from this room to this room. Then he says west. He moves from this room to this room. They can go back and go here. And each time he moves into a room, we see that room's title and that room's description and what other things are in that room. Okay, so we're going to create a little text-based virtual environment that we can take our player and move him through. Okay? So we have to think about who are the things that we're, who are the players that we're going to need to have in the scene? Who are the actors in this scene? Okay, so we have rooms. We have our normal player. This is going to be us. We'll build off our current player. So our normal player, this is the human that will be traversing the world. Okay, so initially, that's all we're going to have. Now, I know if we, use our imagination and we go to the next class and the class after that and the class after that, we start thinking how we can add stuff to our world, where maybe we have, little animals running around. Maybe a cat is, is sitting in this room. And maybe then eventually we want to have that cat able to spontaneously move from room to room to room to room. So we might be standing in this room and all of a sudden a cat wanders in. That should be something that can happen. That kind of is like how video games work. If you're playing a video game, even an older game like Super Mario Brothers, sometimes one of those little mushroom guys comes onto the screen because he's wandering towards you. A lot of times if you look at an old game like that, those guys are on a back and forth pattern. They just go back and forth between 2 points. But in a more modern game, there's a lot more randomness, where you might have something in the game that just kind of wanders the world randomly and they come across your path sometimes. That's just the way it works. All right, so we might want to add a little bit of life to our game eventually. Right now, we want to keep it simple. So we have a dungeon of interconnected rooms. Those rooms are connected to each other. And a player can walk from room to room to room to room. All right, so if we were to kind of flesh this out a little bit, this first room has a list of exits that includes 1 other room. This is the room he can get to. This room has a list of exits that includes 2 rooms, this guy here and this guy here. This room has a list of exits that includes 4 rooms, this guy, this guy, this guy, and this guy. This guy has 1 room as an exit. This guy has 1 room as an exit. This guy has 1 room as an exit. All right, so each time we describe a room, we're going to tell it who his exits are. So we'll have to be able to add an exit to a room, because we're going to have to think of these as like Legos, and we're going to build up our collection of our rooms. All right, so we want to go and describe this. So this is our room. This is our players. This is the human being that's going to traverse this. And initially, a player is going to have a name, and we can have him have an age and a jersey number like we have right now, even though I doubt we're going to use the jersey number. So we could potentially drop that. Eventually, we're going to add like a strength and a dexterity and things like that to our to our players. But right now, we'll just keep our stock player that has a name, an age, and a jersey number. Okay. So what we want to do is we want to go ahead and create our object that represents a room, understanding that we're going to want to create multiple instances of this object. In this case, we're going to create 6 instances of rooms and then link them together like they're Legos. All right. So let's go into our code and let's develop an object for room. So we're going to create a class called room. And for our constructor for this guy, he's going to take in a title, a description. Now, right now, he's not going to take in a list of inhabitants or a list of exits because we haven't put people in there yet and we haven't connected him to other rooms. So a room in and of itself, if we just separate this guy from the rest of the world, we're just looking at him. That is a single room that has a title and a description. Okay? So that's what the constructor for a room will initially build for us. So this guy will take in a title and a description. And we'll set self.title equal to title, self.description equal to description. All right, so that's what a room will look like when we first build it. Now, we probably also want a room to be able to display itself. So def display, especially since we're dealing with a text-based game here. You know, everything is about putting something onto the screen so the human being can kind of recognize where they are in the world. So for a room to display itself, we'll go ahead and show its title and then show its description. So we'll go ahead and we'll print out an F string. So we'll do a formatted string and we'll put in the title and then maybe kick it down a line and put in the description. So this would be self.title. This would be self.description. And that's what a room will look like. All right, so that's initially our rooms. Now let's go ahead and let's create for us our 6 rooms. And then we'll come up with titles and descriptions for them. We might make it easy for us to traverse. So inside main here, we'll go ahead and we're going to create our, we'll call this R1 is going to be a room. And we're going to call this guy, its title will be Cave Entrance. And its description will be the cave entrance. Might want to get a little fancier with what the description looks like, but we'll just say that that's good for this one. And then we're going to create 5 more rooms. All right, so we'll call this guy room 2, room 3, room 4, room 5, room 6. And this guy will maybe be called a dark room. Actually, I probably should have copied from this guy. In fact, I'll do that. That'll be quicker. All right, so these are all dark rooms, and maybe we decide just to give ourselves, maybe this is the final room. This might be where the boss is, something like that. So maybe this guy is I don't know, an open cavern, something like that. We'll call this guy a brightly lit room, which is weird since it's in a cave, something like that. All right, so we've created 6 rooms. You can think of this as being like 6 building blocks, 6 Legos. All right, so if we go back to our picture here, right now they're not organized at all. We just have 6 rooms just kind of sitting out over here. Now we need to connect them together. So maybe this is R1, this is R2, this is R3, R4, R5, and R6. All right, so those represent our variables. Okay, so now we want to start connecting those rooms to each other. Now, in order for that to work, we need to have a way of taking this room and adding a room to it at a particular direction. All right, so when we have an exit, okay, so I mentioned here that a room has a list of exits. We want to think about what is an exit. An exit is a description like north, east, up, something like that. You know, what direction, for instance, the exit leads, and then the room the exit leads to. That's what we'll say initial exit is. So we need now to have an exit object. So we'll go and build that for ourselves. We'll put it up there after room. So we'll have a class exit. Yay. And this guy will have a constructor, and a exit's going to have a, we'll call it direction, and a room destination. And we'll set self dot direction equal to direction, and self dot room destination equal to room destination. Okay, and we'll just say for right now that's what an exit is in our world. We won't make it overly complicated until it has to be. All right, so now what we need to do is we need to go and get some more Legos. We need to build the Legos that represent all the exits. We need an exit right here, an exit right here, right here, right here, right here. So those are all the exits that exist. All right, so this room has 1 exit leading here. This room has 2 exits, one leading back to room 1, one leading into R3. So you actually are going to have to create multiple instances of exits. So for instance, this exit exists twice, this one right here, because we have an exit going from room 1 to the north into room 2. But then we also have an exit going from room 2 to the south into room 1. So for right now, we're going to create those as separate exits. All right, so let's go ahead and create that first one. And we'll name them something convenient for us. So we'll say exit R1 to R2, something like that. This guy will be equal to an exit to the north, and it's going to lead to R2. Exit R2 to R1 will be an exit to the south. That'll lead to R1. So what did we just do there? We created exit R1 to R2, which is an exit to the north that leads to R2. And then we created a second exit that's from R2 to R1, and it's an exit to the south that leads to R1. Okay? Now remember, we decided that a room has a list of exits. So initially what we'll do is inside of room, inside of our constructor for room, we'll set self dot list of exits equal to the empty list. And we'll go ahead and also set list of inhabitants equal to the empty list. Okay, so right now when a room first comes into existence, it has a title, it has a description, it does have an empty list of exits as well as an empty list of inhabitants. There's nothing in there yet. All right, so now what we want to do is we want to have a ability to, I don't know why I called this underscore display. I was in underscore mode, I guess. So we're going to have add exit. And this guy will take in a exit as a parameter. And we'll say self dot list of exits dot append a exit. So that'll add that exit to that room. All right, so now I want to add R1.add exit R1 to R2. And then here I want to say R2.add exit. Got something funky going on up here. List of exits. Dot append exit. Well, looks fine. It's not doing completion for me anymore right now. So add exit R2 underscore R1. So from room 1, I'm going to add an exit. The exit I'm going to add is the exit I just built that leads to the north out of room 1 into room 2. So I just added to this guy an exit that leads here. Similarly, for I created my second exit. For room 2, I added an exit leading from room 1 to room 2. Okay, so for our homework, build all of the exits and connect all of the rooms to create the dungeon structure that we have above. Add a display method to a room that has the room show its available exits, as well as its title and description. So you can test that your connections are working. So in the end, I should be able to come here and say R1.display, for instance, and that should show me cave entrance, the cave entrance, available exit to the north. That's what it should show me. If I print out R2.display, it'll say a dark room, exit to the south, proving that you connected these things up. All right, so do that for your entire dungeon and then have all of your rooms display themselves, proving that you have created this structure. All right, does it make sense what I'm asking you to do? We're playing with Legos here. We're not actually putting players into our world yet. We're just having them go through and we're connecting all our rooms up so that we're ready to put players in. And I've done the first 2 connections for you. All right, so I will see everybody on Friday.